So inverse of square root and quadratic functions. If you look back in your notes, you should see your, when we talked about inverse last time, remember an inverse relationship is when you switched x and y, so switched x to y and y to x. It's when the dependency relationship is switched, independent becomes dependent, so x becomes y. Inverse, you switch all ordered pairs. So if it gave you a table of values like 0, 1, 4, 5, 8, 9, then you would switch it to 1, 0. So these two switched. 5, 4, and then 9, 8. So that's just a reminder of what inverse, and remember we always write it as y to the negative first to show that it's the inverse function. So if we look at our first one, or this is going to be our first example, if we have y equals the square root of x plus 3. So remember the word inverse, I think it's crooked and it's bothering me. The word inverse means to, so first thing you need to do is switch x and y. So if I wanted to write the inverse equation for this, so I'm going to write the inverse equation, first thing I need to do is switch x and y. So it would then become x equals the square root of y plus 3. Now remember when we do these, we don't, or if you don't remember, then this is a crash course, I guess. After you switch it, then you have to do all of the steps to solve for y. We always write our functions as y equals. So I need to solve this equation right here for y. So I'm trying to get y by itself, that's what it means to solve. But it's under a square root. So that's why we did solving square roots first, to remind you that the opposite of taking the square root of something is to square it. So I'm going to do the opposite of taking the square root, so that's going to cancel and that's going to cancel. And then I'm going to square this. So it would become x squared equals y plus 3. Okay, we're going to go ahead and just keep solving for y. So if I want to get y by itself, I need to do the opposite of add 3, which is subtract 3, and subtract 3. Now I can't actually subtract 3 from x squared. I can't change the x squared at all. It would just stay x squared minus 3 equals y. Okay, now if you look at that, it's written with the y at the end. I think I'm going to actually use purple. It's written with the y at the end. Remember I just showed you that to show that it's the inverse equation, you put y to the negative first. That negative first just means inverse, equals x squared minus 3. So that would be our inverse equation. Oh, my computer just froze. Sorry. So that would be our inverse equation. Now I'm going to go ahead and graph them just to show you or to remind you what inverses look like. So if we have the square root of x plus 3, in order to type the square root of x plus 3, hit second and the x squared button, which is right there. And then the x button, which is right here, plus 3. Go to the next one, and we're going to do x squared minus 3. And we're just going to see that, so that's the square root function, and then there is the parabola. remember when you're talking about inverses, so we have one, this was the inverse, and then the original looked like this. So remember their reflection. Just a real quick, we will be talking more about graphs and you'll be graphing these yourself, but there would be another part down here on the original, but this is a square root function, and remember you can't take the square root of a negative number. So we will be talking about that in the next few days, but I just wanted to remind you or show you that the inverse, remember, just switches the table. So if we looked at the table, it would be switched. Okay, so that's the first example. Now let's go ahead and do another one. Okay, so if I gave you the equation y equals x squared minus 3. So notice that's this equation, and we're going to do the same steps. So remember, first thing you always do is switch x and y. So switch x and y and then solve. So it would become x equals y squared minus 3, and then we're going to solve. Pull this down a little bit. Okay, so now we're going to solve. I'm trying to get y by itself. I can't do the opposite of squaring until this is alone. So I need to do the opposite of subtract 3. So I need to add 3 and add 3. That's the same as if we were looking at this equation. If that plus 3 would have been outside of the square root, and just this, it was just the square root of x, like if it looked like that without the square root up there, I would have to move the 3 over. I guess it would be here. I would have to move the 3 over by subtracting, and then I would do the opposite of the square root. So I would have x plus 3 equals y squared. Okay, now I need to, now that this is alone, the opposite of squaring something is taking the square root. So that and that would cancel, and then I would take the square root of everything over here. So then it would be the square root of x plus 3 equals y. We need to write it so that it shows the that it's the inverse equation. So I would write it as y to the negative first equals the square root of x plus 3. Now, if you notice, and this is an important thing, if you notice, the original equation on this one is the inverse of this one. So I took the inverse equation of the first one and I just wrote it as the inverse again. So it ends up just making it back to the same thing. The reason I did the same problem, just going different directions, is I wanted to show you that the inverse of a square root function is a quadratic. So if you think about the square root, and then you think about an x squared, remember x squared makes that parabola, so it's quadratic. This one started out quadratic and ended up as a square root. So I want you to write that. Square root and quadratic functions. Oh good, my pen's going out. Functions are the inverse of each other. So if I were to ask you, what does the inverse of a quadratic equation look like? It would be square root. And if I asked you, what does the inverse of a square root equation look like? And it would be quadratic. Okay, we're going to do one more that is more challenging, just to remind you what things you need to look at. So if I gave you the equation y equals 4 plus 2 square root of x minus 3. Okay, so if you look at that, again, first thing you need to do is switch x and y. Let me zoom out just a little bit so you can see all of that. So I need to write it as x equals 4 plus 2 square root of y minus 3. And then we need to solve for y. This one is going to be more steps, but it's still the same thing. So solve for y. So I'm trying to get that by itself. Well, since it is underneath the square root, I need to get this whole term by itself. So see how, remember when we talked about terms being separated by addition signs? So this is a term and this is a term. We need to leave the term with the y alone. So we need to get this to be canceled first. So it would be 4 minus 4 would make that cancel, and subtract 4. So it would be x minus 4 equals 2 square root of y minus 3. Okay, keep solving for y. So keep solving for y. Again, the y is still underneath. So just like if we had just a, and this is just another side note, if we had just a 2 parentheses y minus 3, and it was just a parentheses, I would have to divide by 2 to get that to cancel. You need to do the same thing with that 2 right here. So the y is still under the square root. It's not just the square root by itself, so I can't just get rid of the square root. I need to get rid of this 2 first. So I need to divide by 2 and divide by 2. So it would be x minus 4 divided by 2 equals the square root of y minus 3. Something to think about here, if you don't like leaving it or not if you don't like, but since it is as a fraction, I'm going to break it up so that it is x over 2 and then minus 4 divided by 2 equals the square root of y minus 3. So if you look at that, minus 4 halves, or 4 divided by 2, would just be negative 2. This would be 1 half. I'm not going to leave it as a fraction. I'm going to change it to its decimal. So 1 half would be 0.5 x. And then negative 4 divided by 2 would just be negative 2. And then equals, again, the square root of y minus 3. In my opinion, I think more students would be more comfortable leaving it like this than leaving it like this in the fraction form. Now it is set up so that it is a square root by itself. So now we can do the opposite of taking the square root. So the opposite of taking the square root is to square it and to square it. that would cancel with that. So it would just be 0.5x minus 2 halves equals y minus 3. The y is still not by itself, so we need to do the opposite of subtract 3, which is add 3, and then add 3. Notice I can't add this to that 2 because there's a parentheses around it. So all I'm going to do is write it as 0.5x minus 2 squared plus 3 equals y. So that's just vertex form for the most part. Last thing I need to do is write it using the inverse. So y to the negative first equals 0.5x minus 2 squared plus 3. And that would be our inverse equation. So that one is definitely more challenging than the other ones. So you will just have to remember to keep working to get the square root by itself in order to get it to cancel. So I couldn't have taken this, I couldn't have squared it here. I had to wait till there.